we're familiar with finding the coordinates of the intersection of two lines in 2 space. We're going to be looking at finding the intersection of lines in 3 space. In other words, we're going to try and find the x, y, and z coordinates that are common to both these lines. Now we're going to start up with these equations written out in their parametric forms. So the x, y, and z coordinates of the first line are given in terms of the parameter s, and the x, y, and z coordinates of the second line are given in terms of the parameter t. Where these two lines intersect, the values of x, y, and z should be equal to each other. And so now it becomes a matter of just finding out what the values of s and t are going to be. So here we have a situation where we have two equations and two unknowns. We can solve these two equations however we like. We could use elimination or we could use substitution. This would be a particularly good pair of equations to use substitution because I know that negative 2s is equal to negative 2t, so s is equal to t. I could substitute that back into my first system of equations and find out what s is. If I wanted to use elimination, I can, and there are my equations to use elimination. And when I do solve them, which is easy enough, I find out that s is equal to negative 1 and t is equal to negative 1. And so the big question now, are the values of s and t that I just obtained going to be consistent with the z value? And so I may have found out where the two lines cross in the xy plane, but if it's not consistent and I wind up with two different z values, I'm in fact dealing with two skew lines that don't intersect at all. So I need to make sure that it's consistent with the z value. And so all I need to do is take s equals negative 1 and substitute it into the respective parametric equations. And what I find out is that indeed I wind up with the same z coordinate for this equation and for this equation. So it is a consistent system, and it's just a matter of finding out what x, y, and z is now by substituting the parameters into the equations.